In this video of the series of adding and subtraction rational expressions, we are going to take it easy and look at how to just add and subtract rational expressions with common denominators, with like denominators already. So this should be quick and easy. If we have a over 15m plus 2a over 15m, I see right away, you know what? I have a common denominator of 15m and 15m. So I can write them together under that one denominator. I can do a plus 2a over 15m, which combined like terms gives you 3a over 15m. Again, what you need to make sure is, can you simplify it? Look at your coefficients. 3 over 15 is really 1/5. And so we have 1a, which is a, over 5m. And that is my simplified expression. So before I started this problem, I looked and I saw, yeah, I have like denominators already. I have common denominators. So I can just put the two fractions together under that denominator, combine like terms, and simplify. The same goes here. I have already an x plus 3 and an x plus 3 in the bottom. I have my common denominator. I don't need to find it. And so I can combine them, doing the operation over x plus 3. So I have 4 minus 1, which is 3. So I have 3 over x plus 3. Now the question I have to ask you is, can you cross out these 3's? And the answer is no. This 3 is attached to a plus sign. It is part of a factor on the bottom. This factor, this object is, 3 more than a number increased by 3. You need that 3 down here to know what this value is. It's attached to an addition and subtraction, so you can't do division with it. And so this is your final answer. You cannot cross out any object, any term attached to a plus or a minus sign. You have to leave it alone. So that's why I wanted to focus on that problem for a little bit, is I want to make sure you understand you cannot cross out if the object is next to a plus or minus sign. Now, I kind of told you that we're going to be dealing with like denominators, but if we look at 10 and 11, well, you would tell me we don't have like denominators. I have a 4k minus 3 and a 3 minus 4k. Those aren't the same, Mr. Rainsberg. Well, they're not, but they are. We learned when we were multiplying and dividing rational expressions that if you have the same terms, a 4k, and a 3, and a 3, flipped positions around a minus sign, they technically are the same terms. They are what we refer to as our additive inverses. We can rewrite them so they are exactly the same. And so what's going to happen is I'm going to work with using this fraction with the additive inverse. So I'm going to keep the first fraction exactly the same. I have 7k plus 2 over 4k minus 3. What I am going to do is use my additive inverse to flip this bottom one around. And so I'm going to write it down underneath it first, and then we're going to see maybe a shortcut to help us out. So when you do that, remember you factor out a -1, and that flips the positions of the numbers around the minus sign. And so really the bottom is -1 times 4k minus 3. And we don't like negatives in top. So what I like to do is I like to take this negative and I like to just put it right to that operation. So if I have a -1 times a positive sign, what that does is it changes it to a minus sign. And that took care of that -1. We don't like to keep it there. We're just going to change it with the operation. And now I have 8k over 4k minus 3. So I do, in fact, have a common denominator. It just was hidden inside this additive inverse. So when you factor out the -1, I take it right to the operation. And that changes it to a minus sign. And so let's combine them together now. And when I combine them together, I'm going to be careful, because we learned in a previous video, this minus sign affects the entire expression in the numerator. This minus sign is going to have to be distributed to that entire expression. So the first thing I write down is my 7k plus 2. But then this minus sign goes to the 8 and becomes minus 8. The minus sign goes to negative k and becomes plus k. And since we have the same denominator, 4k minus 3, I can write it. And now I just combine my like terms. I have 7k plus k, which is 8k. I have 2 minus 8, which is negative 6, over 4k minus 3. Now again, what do we always have to do? After we combine our terms, we need to make sure, can it be simplified any further? Can our numerator be factored? Well, I see 8k minus 6, and I know they have a GCF of 2 in common, so I'm left with 2 times 4k minus 3 over my 4k minus 3. Well, take a look. They have this factor of 4k minus 3 in common. We can cross it out. So the completely simplified form of this is the number 2. So again, these are what I call really cool examples, because this 7k plus 2 over 4k minus 3 plus 8 minus k over 3 minus 4k is just a crazy way of writing the number 2. And that's the cool thing about math, is this such complicated adding rational expressions problem is just the number 2. What we want to make sure is we understand is this additive inverse. So let's look at one more example of this. R minus 1 over R minus 3 plus 9 over 3 minus R. Again, you may say, well, Mr. Rainsberg, they don't have like denominators. Yes, they do. It's just you need to realize this is the additive inverse of this one. And so you have to factor out a negative 1 from it to flip it around. They are the same denominator. It's just hidden from you with this additive inverse. And so again, take this negative 1 and take it to the operations. Right here, it's a plus sign, so a negative times a positive is a negative. So what happens is it turns it into a minus problem. So I have R minus 1 over R minus 3 minus 9. And now I just have my R minus 3. Well, I have the same denominator of R minus 3, so I can combine them together. Negative 1 minus 9 is negative 10. So I have R minus 10 over R minus 3, and we cannot cross anything out because they are attached directly to these minus signs from it. And so that is my final answer. So hopefully you found this a little bit easier, these 4 examples. Now I know 10 and 11 took that additive inverse in there, so it's nice to review that concept and see how we can use it to assist us with adding and subtracting our rational expressions.